Hi, welcome back. It's my tutor Binod. In this video, we are going to talk about GCF, or also known as greatest common factor, or H.C.F, highest common factor of algebraic expression. Later on, we are going to discover about LCM, or lowest common multiple. First, let us start with H.C.F, or also called as GCF, greatest common factor. So let me first tell you about its some uses. If we want to split things, we're gonna use H.C.F to find out how much amount we can get. If we want to distribute equally, we can use the application of H.C.F. Similarly, if we want to arrange something, we can also use the application of H.C.F or G.C.F, greatest common factor. Now let me introduce with you with first example. Let us find the H.C.F of this term, x4y minus x to the power 2 y to the power 3, and the other expression is in below. Let us start with the first expression. In order to find the H.C.F or G.C.F, the first thing you must do is you must try to find whatever the common in between the expression, or in between the terms of the given expression. Suppose we have this term over here. If you see it closely, you can see we have x square common in both the terms of the first expression, and also we have y common. So whatever the common, you can take it out, and the remaining you have to put it inside. Or if you divide the first expression by the common term, you will get x square, because y will be gone, and x4 over x square is x square. Similarly, you do the same thing with the second term. The remaining term you will get for the second term in the first expression is y square. So after taking x square y common, we will have x square minus y square inside the bracket. And now if we want to proceed further, we have x square y. So this is of the form a square minus b square, and the algebraic formula for a square minus b square is a minus b a plus b. So we elaborate it as a minus b a plus b. Of course, in terms of x square minus y square will be x minus y, x plus y. So that's all we can do it for our first expression. Now let us see for the second expression. The second expression is 2x cube y minus x square y square minus x y cube. If you want to see closely, we can get x y common from all of this, because this has xy, this has x square y square, and this has xy cube. Of course, we can take x common from all of them, and also the y common. So xy will be our common multiple of all of these. So whenever we take xy common, the first terms of second expression will have this 2x square as a remaining, so we put it inside the bracket. Similarly, for the second term, when we take out xy common, we will have xy, negative xy for the second term of the second expression. Similarly, negative y square for the third term, because xy is common, so x is gone, and we will be having y square over here. That's why we take common. If you want to proceed it even further, we have xy, then this term will be 2x square. Let us factorize it, because in order to take the GCF or LCM of the algebraic expression, we should know how to factorize. So let us factorize. So the multiple must be 2 in order to factorize, and when we add or subtract, we must have negative 1. So we have 2 times 1 is 1, and 2 2 minus 1 or 1 minus 2 is 1. So we can do minus 2xy plus xy in order to factorize this quadratic term over here. Minus 2xy plus xy minus y square. So if we come inside, we have 2x common in between this. So 2x is common. The remaining will be x minus y, plus in this 2 term we have y common. So we will be remaining up with x minus y. So eventually we will be getting xy, 2x plus y, and x minus y. Now we are supposed to find GCF or H.C.F of these two elaborated from our first expression and second expression. If we want to see it here, what is the greatest common thing in between these two expressions? Let's see. So we can get x common. Of course x is here and x is here. We cannot take x square because we are supposed to take the greatest common factor or the common factor. So I can only take 1x, which is here. Similarly, we have y over here and y over here. Of course I can take that one too. And let's see what else we can take. Let us see what else is common between the two. So this has x minus y and this has x minus y. So of course I can take x minus y as well. Can I take x plus y? No, because there is no x plus y over here. Can I take 2x plus y? No, because it's not here. So whatever the common is in between the two expression, we are supposed to take that and show it as GCF or H.C.F. I hope you understand this example. Now let me introduce you with the second example of GCF. Now the example 2 is a square minus 2a minus 28 plus 16b minus b square is our first term, whereas a square plus 2b minus b square plus 2a is our second term, and similarly a square minus b square plus 4b minus 4 is our third term. So this is the third term, this is the second term we have, and this is of course the first term. Let me show you few algebraic formula in order to easily calculate or easily solve or easily get the H.C.F or G.C.F of the expression. You should be familiar with a plus b whole square formula, which is a square plus 2ab plus b square. Similarly, you must know a minus b whole square formula, which is a square minus 2ab plus b square. And the third most useful formula to get the factorization and hence LCM and H.C.F done is a square minus b square, which is a plus b a minus b. Similarly, a cube minus b cube will be a minus b, a square plus ab plus b square, and a plus b, a cube plus b cube is a plus b, a square minus ab plus b square. So these are the few formula we should know in order to get our things done faster in terms of GCF and LCM. Let us see second example, which I already introduced to you earlier. The first expression is of course a square minus 2a minus 28 plus 16b minus b square. What we can do, let us think for a while. So I can make this term as this one. Let me put as this one, because if I want to split 12a into 2 times 6 times a, because this is a square, so my a term is here, my 2 term is here. If I put 6 here, then later if I put 6 square, I can tell this term as a minus 6 whole square. So let me try to do that. So the first expression is a square, I put it as it is, minus, if I want to split 12a by 2 times a times 6, so 2 times a times 6, plus, if I add in 6 square, I cannot add 6 square, I must subtract the equal amount, because I cannot add anything for free. So I add 6 square and I then subtract 6 square. Now this will be gone and we'll have the same term. But in order to get in the whole square form of this one, I'm trying to get the whole square form of a minus 6 whole square over here. So this is a minus 6 whole square, and the remaining term I write as it is. Now let's see, this is a minus 6 whole square minus the remaining term is b square plus 16b over here, and 6 square is negative 36, negative 36, negative 28 is negative 64. Now let us see. So a minus 6 whole square, if I get minus common from all three terms over here, I would get b square minus 16b plus 64. In the next step, I square this up as it is. It's the same thing over here. Now over here I can again get the terms a minus b whole square form. In this case my a will be my b, so b square minus 2 a is b, or in the formula we have also 8 because 2 times 8 is 16 and 8 is 16b. I can split 16b as 2b8 because 2 times b times 8 is again 16b. Similarly 64, if I want to write it in square form, it's the square of 8. So this thing and these things are equal or equivalent, so the thing over here will become b minus 8 whole square. So this is again a square minus b square form, so which is a plus b, a minus b. My a over here is a minus 6, a minus my b is b minus 8. Since I have two terms in the second one, so I put bracket over here, and then the term is my a minus 6 plus b minus 8. On simplifying, I get a minus b plus 2 and a plus b minus 14. Now let us see second expression. Second expression is relatively easier because it's a little bit simpler. A square plus 2b minus b square plus 2a. In a square minus b square we can put it together, whereas in 2b and 2a we can take 2 common, which will become 2a plus b. Now this is a minus b and a plus b plus 2a plus b. From these two terms we have a plus b common, so I take a plus b common. So in the first term I will be left off with a minus b, whereas for the second term I have only 2, so a minus b plus 2. Similarly, if you want to see the third term, which is again relatively simpler than that of the first term, which is a square minus b square plus 4b minus 4. If you want to put a square aside and then put everything else in the bracket, we will get b minus 2 whole square form, because b square is b square minus, if I want to take b minus 2 whole square, I must have 2. My b is b, or in fact this b, and I can multiply it again by 2, and the 4 I can write it as 2 square, so this is nothing but b minus 2 whole square, this term over here. So a square minus b minus 2 whole square. Similarly, we can use a plus b, a minus b formula over here to get a minus b minus 2, whereas a plus b minus 2 will be over here. On simplification, I get a minus b plus 2, a plus b minus 2. If I want to then compare these two expression, the elaborated form of first, second and third expression, let me see what I can get in common. A plus b is not everywhere, so I cannot take it. Let's see what else I can find. So I have a minus b plus 2 over here. I also have a minus b plus 2 over here. I also have a minus b plus 2 over here, so I can put it here as my common factor. Let me see if I have anything in common. This is not in common everywhere. This is not in all of the three one, and this is not. So this much will be my GCF, or greatest common factor. So the GCF is a minus b plus 2. Now in this example we're gonna try to find the H.C.F or the GCF of n cube minus n square minus n plus 1. The first expression, second expression will be 2n to the power 4 minus 2n, and our third expression is 3n squared plus 3n minus 6. The first expression, let me write as it is for now, and then if I want to take n square common from first two, I'll be having n minus 1. Similarly, if I get negative 1 common between these two, if there is nothing common, you can always take 1 in common, but let me take negative 1 common over here. I would be ended up with n minus 1. So n minus 1 is again common in both two terms, so I put n minus 1 as it is. Then the remaining term will be n square minus 1. I write it over here. Now it will be n minus 1, n plus 1, n minus 1, because n square minus 1 square, which is n minus 1, n plus 1, and I have n minus 1 over here. So this is how I elaborate the first expression in order to find HCF. Now let us see what we can do for the second expression. The second expression is 2n to the power 4 minus 2n. If you want to get 2n common, you will have n cube over here. Then if you divide 2n by 2n, you would get 1, so the remaining part is 1 over here. If you want to further simplify it, you're gonna have 2n n cube minus 1 cube, and this is nothing but the formula. If you have a cube minus b cube, you will have a minus b, a square plus ab plus b square. In this case our a is and our b is 1, so it will be n a minus v a square plus n times 1 plus 1 is square. So this is n minus 1 n is square plus n plus 1. So that's how I got this term over here. Similarly, let us see the third expression, which is 3n squared plus 3n minus 6. I can take 3 common. If I have common in all 3, I can take it, so which will make my problem even more easier. If I take 3 common from here, I would have n squared plus n minus 2. Similarly, if I can now factorize it, if I multiply this expression with this, I'm gonna have 2 times 1. I need 1 over here. 2 minus 1 is again 1, so I can put 2n minus n, which is eventually n in terms of n, in order to factorize. So n squared plus 2n minus n minus 2, 3. I can take n common over here, it will give me n plus 2. Similarly, I can take negative 1 over here, which will give me n plus 2 again, which would be 3n minus 1, n plus 2. So that's why we can factorize the third expression. Now let us see what we have in common in all the 3 expressions we have here. So the first expression, let me start with n minus 1. I have n minus 1 over here. I have also n minus 1 over here. Similarly, I have n minus 1 over here. So there is n minus 1. Let me see what else I have. N plus 1. Do I have n plus 1 in other place? No. So this is not our greatest common factor. Let me see n minus 1, which I already did, which is common in all 3. Now let's see. This is not common in all the 3, whereas this is also not in common in all the 3. So what are in common in all the 3? What is the greatest factor we have in common in all the 3? And that's only n minus 1 in this example. So our GCF or HCF would be n minus 1. That's how we do it. I hope this video is helpful to you to find the GCF of the algebraic expression. Stay safe and healthy. See you later. Thank you.